Why, hello there, mathematicians. We learned about simplifying radicals by doing a Desmos activity together online. So you guys should have sorted your cards as such. Some of you used your calculator or the Desmos calculator to help you find that they were equal to one another in terms of decimal. But a couple of your classmates made some key observations. In particular, we were looking at the square root of 24 and the square root of 54. So you guys noticed that the square root of 24 came from either 4 times 6, which gave you the 2 square roots of 6 on the outside there, or some of you noticed that it's 2 times 2 times 6, and that pair of 2 created the 2 on the outside. Now, the square root of 54 you noticed was either 9 times 6, which gave you that 3 on the outside and the root of 6, or you guys noticed it's 3 times 3 times 6, which again made the 3 on the outside and the 6 stays in the inside root. So a couple other notifications that you guys found were the following as you worked through your Desmos activity. We took a little bit of notes because you noticed some of these patterns. So again, some of you realized that 27 comes from 9 times 3, which means that the 9 is a 3 by 3, or 3 times 3. Or some of you realized that 3 times 3 times 3 is 27. So again, that piece here, that 9 times something would help us get that 3 by 3 on the outside. Or you use the 3 times 3 times 6 or 3 times 3 times 7. So that's a really key idea that that part goes outside and the stuff that stays inside the radical is the 3, the 6, and the 7 as my multiplier. So we had asked you guys what would be equivalent to this form 3 square root of 11. So some of you would have taken that as 3 times 3 times 11 or 9 times 11 would help us get that simplification there, which means literally we would multiply those, which would be 3 times 3 times 11 or 9 times 11 is 99 underneath the square root. All right, so using that idea, we also talked about the third slide on Desmos here. So again, you guys noticed that you could use 25 times 3, 25 times 6, or 25 times 7. And again, 25 comes from a square, a 5 times 5. Or some of you wrote out those 5 times 3 and 6 and 7. So again, we asked you this interesting question. What is equivalent to the square root of 275? So you guys ended up taking 275 and dividing it by 25 and getting 11. And you noticed that 25, again, is a perfect square. That is a 5 times 5, a 5 by 5. Some of you also wrote it out as 5 by 5, 5 times 5, times 11. So we end up getting that this is equivalent to a 5 on the outside and 11 stuck in. All right. So another quick question was, a student says that 5 square roots of 10 is equivalent to the square root of 250. Without using your calculator, how could you figure this out? And a lot of you told us that 25 times 10 is 250, or that if you take 5 times 5 times 10, it is also 250. So then we asked you to write different formats of the square root of 360. Now, what is one possible equivalent form? We actually found 3. So you guys noticed we could have used 36 times 10 or 6 times 6 times 10 to get 6 square roots of 10 as a simplified form. Or we could do 9 times 40 or 3 times 3 times 40. That gave us 3 square roots of 40 as a simplified form. Or we could have done 4 times 90, which was 2 times 2 times 90, which meant we had 2 square roots of 90 as a possible equivalent form. So a couple of things that you noticed was that if I used the 6 times 6 times 10, this guy gave us the most simplified version. And that will come in handy tomorrow.